Good evening, everyone. This is Shambhavi. Welcome to VEDANTU Karnataka. Hope all of you are doing good and great. Kindly just let me know if my audio and video is clear. Let me also check here. Am I audible? Hello. Good evening, Anita. Hope my video is also clear. Hello. Good evening, Anita. Yeah, I think it's fine here. How are you all? Yes. Okay. Thanks for your response, Sumit and Anita. Yes, very good evening to everyone. Yeah, thank you. Thank you for your Teachers' Day wishes as well. Okay. Yes. Yeah. Fine. I think we can just start with this session. Let us hope that we are going to finish the motion in a plane chapter today. Okay. I think we are almost done with the major portion in this chapter. That is, we completed the major projectile motion and problems on that. So the only one thing which is left is circular motion. So we'll, here circular motion will just take the circular motion as an example for a motion in 2 dimension or a motion in a plane. Okay. But again, in laws of motion and work energy power chapter, you are dealing with circular motion again in little more detail. So here I'll give some basic and fundamental ideas of circular motion. Again, in in the upcoming chapter, it comes again and we'll discuss again on those topics, because to discuss certain parameters we need to have the knowledge of friction, potential energy and all. So that portion of circular motion I prefer to discuss in the other chapters. Okay, I'm just trying to follow as it is given in NCERT. Okay, hope that will be fine with everyone. Yes, good evening, Kirtana. Good evening. What is the name? Chalavadi. Good evening to everyone. So I think there were 2 or 3 questions that were left in our previous session. So we'll just quickly take those 2 or 3 problems and then we'll start with this particular circular motion concept. Okay. So what we have, the problems that are left were, one is this: a plane is flying horizontally at 98 meters per second and releases an object which reaches the ground in 10 seconds. The angle made by it while hitting the ground is. Okay, so this is one problem which we have to consider. So if you clearly observe, okay, so there is a word which is given like a horizontally. This word itself should clearly guide you that the problem is on horizontal projectile motion. Okay, so whenever any object is released with certain horizontal velocity, we know that it is not going to just fall off straight, right? It is not going to take a straight line path. So when we throw it with certain horizontal velocity, we already understood that it is going to take a parabolic path, and we classified that as horizontal projectile motion. So if I just need to draw that, so it just comes out to be something like this. We can draw. So let us say, a plane is dropping some object. Okay, so let us say at this point it has been dropped, and we know that once it is dropped with certain horizontal velocity, the particle is not just coming straight line, it is taking a parabolic path, right? So it takes something like this. correct? And now we have to find out the angle made by the object with the ground while hitting. Okay, so here the angle made by the object means we have to take the angle made by velocity. Okay, so at this point, if I draw a tangent, okay, something like this. Okay, let me take a line and draw it, that's better. So yeah, hope it looks like a tangent at that point. Now we had to resolve this. Okay, we had to resolve this into components. So one is along this horizontal and the other is along this vertical. Okay, so let me, yeah. Okay, so now hope this diagram is clear. So at this point it is, yeah, hope this is fine. I think you can see it. I'm trying to show that endpoint neatly, but some issue here. Okay. Just a second. Yeah, so now I think it will not fluctuate as much. Okay, so now this is our velocity of the particle while hitting the ground. Okay, and now we have resolved it as Vx and Vy, and let me take the angle between this total velocity and the horizontal direction as theta. Now we have to find out what is this angle theta. That is the question. Okay, hope everyone are following. Yes, I think somebody got the answer. Yes, we'll work out quickly. Okay, and now it's a very simple resolving concept based. Tan theta is equals to Vy by Vx. This is always true. Okay, when we have resolved two vectors along perpendicular direction, if we have defined theta with respect to the horizontal direction, then tan theta will be always vertical component by horizontal component. Okay, so illi Vx ಏನು 98 meter per second. Okay, Vx will be equal to 98 meter per second. Okay, because there is no acceleration along horizontal direction, so till it reaches the ground its velocity remains the same, but we have to find out Vy. How do we find out? So along vertical direction we know that, so this is our y-axis and this is our x-axis, right? So along the vertical direction we have acceleration due to gravity, so Vy can be written as uy plus gt kind of a thing, correct? But this uy goes to 0 because initial velocity along vertical direction is 0, correct? Uy is 0 and ux is 98 meter per second. Sarina? So ಏನಾಗುತ್ತೆ uy 0, initially there is no vertical component of velocity, so Vy will be simply equal to, so let me just write here, Vy is equals to g into t we will get. Okay, so ಈಗ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ g ಅಂದ್ರೆ 9.8 ತಗೊಳ್ಳಿ into time ಎಷ್ಟಿದೆ 10 ಅಂತ ಇದೆ, which is going to give you 98 meters per second. And ಈಗ tan theta formula ಏನಿದೆ, so that is like tan theta is equals to Vy by Vx, or this is going to give you theta is equals to tan inverse of 98 by 98, which is nothing but tan inverse 1, which will give you theta as 45 degrees. Okay, so this is how you do. Hope you understood that it's a problem based on horizontal projectile motion. So whenever you get a problem where it is trying to say like some object is in projected horizontally, if you find a word like horizontally, just once recheck, like whether this problem is related to horizontal projectile motion. Okay, some problem will be given like a bomb has been dropped from an aeroplane, something like that. Okay, so that means it's again horizontal projectile motion. Okay, hope that is fine. Yes. Yes, Anvesha, very good. Your answer is correct. Option 2, 45 degree. Your efforts are appreciated. Hello at SP. What is your name? How do I pronounce that? SPG, shall I say? Hello at Rohini. Yes, very good evening to everyone. So you are asking the next class. When is next class? Like my class you are asking or someone else's class? Like you have a next session from 8 o'clock, no? I think Catherine ma'am's class is there from 8 to 9, and then 9 to 10 might be Supri sir class is also there if I'm not wrong today. Yes, hope many of you have got the answer, and I think we can move to next question quickly. So here is the next question. So this I'll give you the hint and the formula, and your job is to complete the problem. Okay, so this will be going to be a homework problem. It's a simple straightforward question. A bomber is flying horizontally. Again, see here, a bomber, okay, or a bombing flight is flying horizontally, means it's a horizontal projectile motion based problem. That is how you have to identify which formula to take in the projectile motion, whether it's an point to point projection, or ground to ground projection, or horizontal projection, or projection on an inclined plane. So you have to look for these words that will guide you. Okay, at a constant speed of 150 meter per second. That means they are giving you ux. Okay, 150 meters per second at a height of 78.4 meters. So we can take h, or you can also take it as y. So 78.4 meter. The pilot has to drop a bomb at the enemy target. Okay, so we have some enemy target and we have to drop a bomb to that particular target. At what horizontal distance from the target should he release the bomb? So ಎಷ್ಟು horizontal distance ಅಲ್ಲಿ the bomb should have been released ಅಂತ ಕೇಳಿದ್ದಾರೆ. Okay, so ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಅಬ್ಸರ್ವ್ ಮಾಡಿ again, if I just have to draw this, so ಏನಾಗಿರುತ್ತೆ, just a second. Yeah, so now if this is our target, let us say enemy target. So if I just drop the bomb at this point, ಏನಾಗುತ್ತೆ, this is not going to hit the target because it is going to take a trajectory like this. Yes or no? So it's going to take a parabolic path. That means if the target is here, okay, if the target is here, so ಏನಾಗಿರುತ್ತೆ, we had to release the bomb at some point so that the range of the bomb is equals to the target horizontal distance. So this distance, that is what we have to find out. Okay, we are supposed to find out this particular distance, r, range. Okay, is that fine? So from here, let me say this is a plane from where the bomb has been dropped with some horizontal velocity of 150 meters per second. Okay, we are dropping from that point so that it flies off in a parabolic path and it hits this target. Okay, so that means what we are supposed to find out, we are supposed to find out the range, and range formula, range is equals to ux into t. Hope you know that. I have given it to you in the last class, right? So range is equals to ux into t, or t can be written as what? Square root of 2h by g. So in the case of horizontal projectile motion, so we are going to have the time of flight as root of 2h by g. So range you can calculate, I hope. So all the values are there. H means 78.4, g take it as 9.8, and quickly substitute and simplify. So So solve it as a homework question. Hope that is fine. I think we can move to next question. Quickly respond in the chat box if you are following there. And also, okay, you calculated time separately. That's also fine. It's up to you. Okay, you can directly calculate or you can substitute in the final formula. Okay, so shall we move to next question? Hope you're following this session. Please give me a thumbs up in the chat box and also do like the videos. Okay, so here is the next question. A particle is projected from the bottom of an inclined plane of inclination 30 degree. Okay, ಇಲ್ಲಿ inclined plane ಅಂತ ಇದೆ. So this is the projectile motion on the inclined plane for problem. So angle of inclination ಅಂದ್ರೆ alpha ಅಂತ ತಗೊಂಡಿದ್ವಿ ನಮ್ಮ ಫಾರ್ಮುಲಾದಲ್ಲಿ. So that is given to you as 30 degree. At what angle from the horizontal, please underline this word, from the horizontal should the particle be projected to get the maximum range on the inclined plane? So range maximum agbeku andre, okay, so range has to be maximum agbeku andre at what angle with respect to the horizontal. Okay, ಅಂದ್ರೆ ಇಲ್ಲಿ ಅವರು ಥೀಟಾ ಡೈರೆಕ್ಟ್ ಆಗಿ ಕೇಳ್ತಾ ಇಲ್ಲ. ನಾನು ಫಾರ್ಮುಲಾದಲ್ಲಿ ಏನು ಹಾಕ್ಸಿದೀನಿ, ಥೀಟಾ ಅಂದ್ರೆ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದಿ ಇನ್ಕ್ಲೈನ್ ಪ್ಲೇನ್ ಅಂತ ಇತ್ತು. ಸೊ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಹಾರಿಜಾಂಟಲ್ ಎಷ್ಟಾಗತ್ತೆ ಅಂತ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಓಕೆ, ಸೊ ಸಿಂಪಲ್ ಆಗಿ ಡ್ರಾ ಮಾಡಿದ್ರೆ, ಸೊ ದಿಸ್ ಇಸ್ ಅವರ್ axis, let us say horizontal direction, this is our inclined plane and this is our u, let us say. Okay, so this is u, this angle we have taken as alpha, this is our x-axis, this is the inclined plane, and this angle we have taken as theta. Okay, so we know the condition for theta in terms of alpha to get maximum range, which is given as theta is equals to pi by 4 minus alpha by 2. Pi by 4 andre ಎಷ್ಟು 45 degree, right? 45 degree minus alpha by 2. ಇಲ್ಲಿ ಆಪ್ಷನ್ಸ್ ಎಲ್ಲ ಡಿಗ್ರಿ ನಲ್ಲಿ ಇದೆ, ಫಾರ್ಮುಲಾ ಡಿಗ್ರೀಸ್ ಅಲ್ಲಿ ಹಾಕೊಳ್ಳಿ. ಸೊ ಈಗ theta is equals to 45 degree minus alpha andre 30. So 30 by 2 andre 15. So 45 minus 15 will give you again 30 degree. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, theta 30 degree ಆಗುತ್ತೆ. ಬಟ್ ಅವ್ರು ನಮಗೆ ಕೇಳಿರೋ ಆಂಗಲ್ ಯಾವುದು, this whole angle. Okay, so let me call this whole angle with respect to the horizontal as theta dash. So theta dash ಅನ್ನು ಹೆಂಗ್ ಬರಿಬೋದು ಈಗ, theta dash is equals to theta plus alpha ಆಗುತ್ತೆ, that is 30 degree plus 30 degree, which is going to be 60 degrees. Okay, so option 2 is the correct answer. Yes, hope it is. Yes, yes, Kirtana, your answer is correct, 60 degree. So you have tried it. What about others? Yeah, I think somebody has responded for the previous homework question also, 600 meters. That is also correct. Very good. Anvesha, right? Very good. Yeah, I think we can go ahead. So yeah, quickly respond in the chat box whether we are good to go ahead. Do like the videos, give me a thumbs up in the chat box as well. Okay, so as I said, now we'll be moving to the basics of circular motion. Okay, basics of circular motion. So circular motion andrenu, till now what we have discussed one which is motion is in a straight line, like the particle continues to move along one particular direction. There was there is no acceleration, so that it was moving along a straight line. And then we also had talked about motion under gravity, again free fall cases. The motion of the particle is still in a one dimension, but it is an accelerated one, uniformly accelerated one. So then also we had some non-uniform motions as well. And then we have moved on to motion in two dimension, that is your projectile motion. So circular motion is also an example for a two-dimension or a motion in a plane. Okay, so this is also an example for two-dimensional motion. So ಇಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, the particle will start to move in a circular path. Okay, so ಏನಾಗಿರುತ್ತೆ, the particle will start to move along a circular track. So if this is the particle, let me say this is some center O, this is the radius R, the particle continues to move along the circumference. Okay, so ಏನು ಮಾಡುತ್ತೆ, it tries to move along this circumference. Okay, so that is called as a circular motion. Yes, Charan Reddy, very good evening. Hope you are following this session as well. Yeah. Okay, so now it need not to be always a one complete circle. So if we have some kind of a curve motion, so something like this, the particle is moving along this path, let us say. So illu enagatte, I can consider this portion as a part of a circle. Again, this portion as some part of some another circle. This portion can be considered as the part of some other circle, like this. So any curvilinear motions can be imagined as part of the circular, instantaneous circular motion. So ಅದಕ್ಕೆ particular radius ಬೇರೆ ಇರುತ್ತೆ, ಅದಕ್ಕೆ particular center of curvature ಬೇರೆ ಇರುತ್ತೆ, but we can imagine like it's the the part of a circle. Okay, and we can also have a complete circular motion, just like let us imagine a circular track, and someone might be running there, or some kind of a bike race, or some kind of race is going on there. So those are all going to be some examples for circular motion. Okay, yeah, any doubts, feel free to ask in the chat box. And also, if you are new to the channel, please do subscribe to the channel. And also, if you are following the session, do like the videos. Okay, I hope there are no doubts. Yeah. So ಇಲ್ಲಿ ಎರಡು type of circular motion ಬರುತ್ತೆ. ಒಂದು uniform circular motion, which we are going to discuss now. The other one is non-uniform circular motion. So uniform circular motion we are going to discuss here. Okay, non-uniform circular motion discuss ಮಾಡೋದು one is in the chapter of work energy power. Okay, ಆ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಒಂದು ಮೋಷನ್ ಇನ್ ಎ ವರ್ಟಿಕಲ್ ಪ್ಲೇನ್ ಅಂತ ಬರುತ್ತೆ. Okay, I mean circular motion in a vertical plane. So I can have a circular motion in this horizontal plane, right? So let me say this is some plane, horizontal plane. I can have a circular motion on top, on this plane, right? So imagine like a stone is tied by a string, and you give a horizontal rotation to it. It's a horizontal plane. Then I can also have this vertical plane, right? I can have this vertical plane, and again the same thing, the stone can be rotated in this vertical plane. Okay, so that in the case of vertical plane or vertical circular motion is an example for non-uniform circular motion. Okay, so ಅದನ್ನ ನಾವು ವರ್ಕ್ ಎನರ್ಜಿ ಪವರ್ ಚಾಪ್ಟರ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀವಿ, ಬಿಕಾಸ್ ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಎನರ್ಜಿ ಕನ್ಸರ್ವೇಷನ್ ಬಗ್ಗೆ ಎಲ್ಲ ಐಡಿಯಾ ಬೇಕು, ಫಾರ್ ದ್ಯಾಟ್ ರೀಸನ್. ಓಕೆ, ಸೊ ಯೂನಿಫಾರ್ಮ್ ಸರ್ಕ್ಯುಲರ್ ಮೋಷನ್ ಅಂದ್ರೆ ಏನು ಅಂತ ನೋಡೋಣ ಫಸ್ಟ್. ಸೊ ಇಲ್ಲಿ ಒನ್ ಇಸ್ ಮೋಷನ್ ಇನ್ ಅ ಹಾರಿಜಾಂಟಲ್ ಪ್ಲೇನ್. ಓಕೆ, ಇಟ್ ನೀಡ್ ನಾಟ್ ಟು ಬಿ ಆಲ್ವೇಸ್ ಹಾರಿಜಾಂಟಲ್ ಪ್ಲೇನ್ ಅಲ್ಲಿರೋ ಎಲ್ಲಾ ಸರ್ಕ್ಯುಲರ್ ಮೋಷನ್ uniform circular motion ಆಗಬೇಕು ಅಂತಿಲ್ಲ. But if there is a particle which is showing a horizontal circular motion with constant speed, the speed of the particle, velocity alla, speed I am highlighting, the speed of the particle is constant, then we call that as uniform circular motion. Okay na? So uniform circular motion andre ಏನು? Yeah, in a circular motion the speed of the particle should remain constant. We call that as uniform circular motion. So non-uniform circular motion ಅಂದ್ರೆ ಏನಾಗಿರುತ್ತೆ, ಅಲ್ಲಿ ಸ್ಪೀಡ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರಲ್ಲ. The speed varies with time ಆಗಿರುತ್ತೆ. Okay, so we'll have a term like dv by dt. ಇಲ್ಲಿ ಸ್ಪೀಡ್ ಇರಲ್ಲ, ಸ್ಪೀಡ್ ಏನಿರುತ್ತೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ, ವೇರಿ ಆಗಲ್ಲ. dv by dt 0 ಆಗಿರುತ್ತೆ. ವೆಲಾಸಿಟಿ ಅಲ್ಲ, ಯಾಕೆ ಅಂತ ಹೇಳ್ತೀನಿ. So let us understand why only it is speed. Okay, so let us say this some circular track is there, and let us say there's a particle here. Okay, so at this point let me say the velocity of the particle can be given by the tangent. Hope you agree. Yes or no? the velocity can be given by the tangent to the circular path, any kind, right? If you are given with the path of a particle, if you draw a tangent at every point, that is going to give you the velocity of the particle. So ಈಗ ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, if the particle had no force, ಅಲ್ಲಿ ಫೋರ್ಸ್ ಯಾವುದು ಇರಲಿಲ್ಲ ಅಂದ್ರೆ the particle should have continued in this tangential direction. Yes or no? Yes or no? Correct alva? If there was no force, yeah, the particle should have continued to move along the straight line. ನಮಗೆ ಗೊತ್ತಿದೆ ಅದು ಫ್ರಮ್ ಮೋಷನ್ ಇನ್ ಒನ್ ಡೈಮೆನ್ಷನ್ ಗೊತ್ತಿದೆ, ನಿಮಗೆ ನ್ಯೂಟನ್ಸ್ ಫಸ್ಟ್ ಲಾ ಸೆಕೆಂಡ್ ಲಾ ಎಲ್ಲ ಗೊತ್ತಿದೆ ಈಗ, ಕರೆಕ್ಟಾ? ಅದೇ ತರ ಇಲ್ಲಿ ಯಾವ್ದೋ ಒಂದು ಪಾಯಿಂಟ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀನಿ ಇವಾಗ. ಅಗೈನ್ ಅಲ್ಲಿ ಟ್ಯಾಂಜೆಂಟ್ ಡ್ರಾ ಮಾಡಿದ್ರೆ that is going to give me the velocity at that point. Correct? So ಏನಾಗಿದೆ ಇಲ್ಲಿ ವೆಲಾಸಿಟಿ ಹಿಂಗಿದೆ, ಬಟ್ ಈಗ ಇಲ್ಲಿ ಯಾವುದು ಫೋರ್ಸ್ ಇರಲಿಲ್ಲ ಅಂದ್ರೆ ಅಗೈನ್ ಏನಾಗ್ತಿತ್ತು, the particle should have continued in this direction. Again, if I choose some other point over here, so again tangent draw ಮಾಡಿದೀನಿ, so that is giving me velocity. Yes or no? So ಇಲ್ಲಿ ಒಂದು just pay attention, this is some important concept. So ಇಲ್ಲಿ velocity ಇದೆ, again ಇಲ್ಲಿ force ಇರಲಿಲ್ಲ ಅಂದ್ರೆ ಏನಾಗ್ತಿತ್ತು, the particle should have continued in this direction. But ನಾವೇನ್ ನೋಡ್ತಾ ಇದೀವಿ, the particle is showing a complete circular motion. Correct? Particle ಏನಾಗ್ತಿದೆ, it is bending at every point. Correct? Yes or no? So ಹಿಂಗ್ ಹೋಗ್ಬೇಕಿದ್ದು, so ಬೆಂಡ್ ಆಗಿ ಈ ಕಡೆ ಬಂದಿದೆ. Again, at each and every point ಏನಾಗಿದೆ, the particle is taking an inward curve, right? ಇಲ್ಲ ಅಂದ್ರೆ particle would have been escaped. But ಇಲ್ಲಿ ಏನಾಗ್ತಿದೆ, every point it is taking some inward curve. ಅಂದ್ರೆ ಒಳಗಡೆಯಿಂದ ಯಾವುದೋ ಫೋರ್ಸ್ ಇದೆ, the direction of the force is inside ಅಂತ. Okay? So outside ಇದ್ರೆ particle would have been escaped, right? Or force ಇರಲಿಲ್ಲ ಅಂದ್ರೆ it would have just gone in the forward direction. ಅದರ linear path ಅಲ್ಲಿ ಹೋಗ್ತಾ ಇತ್ತು. But ಏನಾಗಿದೆ, every point ಅಲ್ಲೂ at every point on this circular track there is some inward pulling force. Okay? So ಅದನ್ನ ಏನಂತ ಕರಿತೀವಿ, so yeah, there is some inward force. Let me say at this point if I draw, so ಏನಾಗಿರುತ್ತೆ, ಇಲ್ಲಿ ಒಂದು inward force act ಆಗ್ತಾ ಇದೆ, so ಇಲ್ಲಿ ಒಂದು inward force act ಆಗ್ತಾ ಇದೆ. Okay? Every point there is an inward force which we call it as centripetal force. Okay? So circular motion ಬೇಕು ಅಂದ್ರೆ ನಮಗೆ centripetal force ಇರಲೇಬೇಕು. Centripetal force ಅಂದ್ರೆ ಏನು, center seeking force ಅಂತ. Okay? So every point ಅಲ್ಲೂ ಆ ಫೋರ್ಸ್ ಇರಲಿಲ್ಲ ಅಂದ್ರೆ the particle would have continued its motion along the straight line ಆಗಿರ್ತಿತ್ತು. ಅಥವಾ if the particle is, I mean if the force is acting outward ಆಗಿದ್ರೆ ಏನಾಗ್ತಿತ್ತು, again ನಿಮ್ಗೆ ಈ ತರ ಕ್ಲೋಸ್ಡ್ ಪಾತೆ ಬರ್ತಿರ್ಲಿಲ್ಲ, ಪಾರ್ಟಿಕಲ್ ಹೆಂಗೋ ಹೊರಟೋಗ್ತಾ ಇತ್ತು. ಬಟ್ ಇಲ್ಲಿ ಏನಾಗಿದೆ, ಎವ್ರಿ ಪಾಯಿಂಟ್ ಅಲ್ಲೂ the particle is bending inward ಇದೆ ಅಂದ್ರೆ there must be some force which is acting inward, which we or towards the center. ಎಲ್ಲಾ ಪಾಯಿಂಟ್ ಅಲ್ಲೂ inward direction ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ it must be acting towards the center, and hence we call it as centripetal force. Okay? Is that fine? ನೆಕ್ಸ್ಟ್ ಅಲ್ಲಿ ಅದ್ರ ಡೆಫಿನಿಷನ್ ಕೊಡ್ತೀನಿ ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್ ಎಂದು, ಇಲ್ಲಿ ಜಸ್ಟ್ ಐಡಿಯಾ ಕೊಟ್ಟೆ. ಸೊ ಈಗ ಏನಾಗಿದೆ, velocity is a vector quantity. We know that it is a vector quantity. Okay? Velocity is a vector quantity. So ಅಂದ್ರೆ ಏನರ್ಥ, ಇದಕ್ಕೆ ಡೈರೆಕ್ಷನ್ ಇದೆ, ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಇದೆ. Okay? So the magnitude of velocity ನೇ ನಾವು ಸ್ಪೀಡ್ ಅಂತ ಕರೆಯೋದು. Speed is nothing but the magnitude of velocity. In the case of uniform circular motion, this speed must remain constant. Constant ಇರಲಿಲ್ಲ ಅಂದ್ರೆ ನಿಮಗೆ ಪ್ರಾಪರ್ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ಇರಲ್ಲ, ಅಲ್ಲಿ ಅದು ಎಲಿಪ್ಟಿಕಲ್ ಪಾತ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಓಕೆ? ಆರ್ ಸ್ಪೈರಲ್ ಪಾತ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ದಟ್ ಡಿಸ್ಕಷನ್ ಇಸ್ ನಾಟ್ ನೀಡೆಡ್ ಫಾರ್ ನೌ. ಸೊ ನೆಕ್ಸ್ಟ್ ಇಯರ್ ಅಲ್ಲಿ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಬರುತ್ತೆ ನಿಮಗೆ, ಹೆಲಿಕಲ್ ಪಾತ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀರಾ. ಸೊ ಬಟ್ ಫಸ್ಟ್ ಇಯರ್ ಅಲ್ಲಿ ಏನು, ಸೊ ಸ್ಪೀಡ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ, ಸ್ಪೀಡ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದ್ರೆ ರೇಡಿಯಸ್ ಫಿಕ್ಸ್ಡ್ ಇರುತ್ತೆ. ಸೊ ಆಗ ನಿಮ್ಗೊಂದು ಪ್ರಾಪರ್ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ಇರುತ್ತೆ. ಸೊ ಅಂದ್ರೆ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ದಿ ವೆಲಾಸಿಟಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ, ಬಟ್ ಡೈರೆಕ್ಷನ್ ಆಫ್ ವೆಲಾಸಿಟಿ ಎವ್ರಿ ಪಾಯಿಂಟ್ ಅಲ್ಲೂ ಚೇಂಜ್ ಆಗ್ತಿದೆ. ಬಿಕಾಸ್ ಎಲ್ಲೇ ನೀವು ಡ್ರಾ ಮಾಡಿದ್ರು ಇಟ್ ಇಸ್ ಅಲಾಂಗ್ ದಿ ಟ್ಯಾಂಜೆನ್ಷಿಯಲ್ ಡೈರೆಕ್ಷನ್ ಇದೆ. ಕರೆಕ್ಟ್? ಎಸ್ ಆರ್ ನೋ? the direction of velocity keeps on changing. That is very important. Okay, so let me say this direction changes from point to point. Got it? Yes. Yeah, who is it? Yes, Guru Raj, MVSAT ಈ ಸೆಷನ್ ವಿಡಿಯೋದು ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಹೋಗಿ ಅಲ್ಲೇ ನಿಮ್ಗೆ ರಿಜಿಸ್ಟ್ರೇಷನ್ ಲಿಂಕ್ ಇದೆ ನೋಡಿ, MVSAT ರಿಜಿಸ್ಟರ್ ನಾವು ಅಂತಿದೆ. ಯಾವುದೇ ವಿಡಿಯೋಗೆ ಹೋಗಿ ವೇದಾಂತದ್ದು ಈಗ ಯಾವ ಲೈವ್ ಕ್ಲಾಸಸ್ ಹೋಗ್ತಿದೆಲ್ಲ ಅದು ಯಾವ್ದ್ರದ್ದೇ ವಿಡಿಯೋ ಹೋದ್ರು ಅದರ ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಅಲ್ಲಿ ನಿಮ್ಗೆ ರಿಜಿಸ್ಟರ್ ಫಾರ್ MVSAT ಅಂತ ಒಂದು ಲಿಂಕ್ ಇದೆ, ಸರಿನಾ? ಅಲ್ಲಿ ಕ್ಲಿಕ್ ಮಾಡಿ ರಿಜಿಸ್ಟರ್ ಮಾಡಿ. ಇಸ್ ದಟ್ ಫೈನ್? I hope it is clear. Yeah. So ಏನಾಗಿರುತ್ತೆ, ಯೂನಿಫಾರ್ಮ್ ಸರ್ಕ್ಯುಲರ್ ಮೋಷನ್ ಅಂದ್ರೆ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ವೆಲಾಸಿಟಿ ಅಂದ್ರೆ ಸ್ಪೀಡ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ, ಬಟ್ ಡೈರೆಕ್ಷನ್ ಎವ್ರಿ ಪಾಯಿಂಟ್ ಅಲ್ಲೂ ಚೇಂಜ್ ಆಗಿರುತ್ತೆ. ದೆನ್ ಓನ್ಲಿ ವಿ ಗೆಟ್ ಎ ಸರ್ಕ್ಯುಲರ್ ಮೋಷನ್. ಐ ಮೀನ್ ಸರ್ಕ್ಯುಲರ್ ಮೋಷನ್ ಡೈರೆಕ್ಷನ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ, ಇಟ್ ವುಡ್ ಹ್ಯಾವ್ ಗೋನ್ ಇನ್ ಅ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಪಾತ್ ಆಗಿರ್ತಿತ್ತು. Then we cannot define anything like acceleration and all in this case. Okay, so now we'll just quickly move on to some terminologies that we will be using in uniform circular motion. So one is angular displacement. Usually theta ಇಂದ represent ಮಾಡ್ತೀವಿ or d theta ಇಂದನೂ represent ಮಾಡ್ಬೋದು. So ಇಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, when you take an circular motion, so if I say this is some circular track and we have our let us say this is our radius initially. Okay, let me draw two lines here. So let me say this is our P1 position, this is P2. Initially the particle was here, after some time the particle moved to the position P2. Okay, and this is representing the radius. So illenagirutte, as the particle moves along the circumference of the circle, it covers some angle. Okay, so which we call it as angular displacement. Okay, angular displacement andre eno, it is the angle covered. Okay, d theta, angle covered with respect to some reference line. Okay, initial point na yavado reference agi itkotira. Okay, this is our center of the circle. So what is the angle covered with respect to some reference line? We call it as angular displacement theta, or we can also call it as d theta, and this is going to be an axial vector. Okay, and if the particle is moving in the anti-clockwise direction, so direction of d theta ellirutte, so you have to curl along that anti-clockwise direction. Thumb gives the direction of angular displacement. Okay na? So angular displacement enagirutte, so the thumb gives the, you take the right hand, curl along the direction of the particle circular motion, whether it is in the clockwise or anti-clockwise. So clockwise madidre thumb is pointing outward baratte, ade tara I mean anti-clockwise madidre thumb is pointing outward baratte, ade tara clockwise rotation ide thumb is pointing inward baratte. So the thumb of the right hand, when we curl along the direction of the particle motion, the thumb which is held perpendicular to these curling fingers gives the direction of angular displacement ಆಗಿರುತ್ತೆ. So that means it is acting along the axis of rotation. I can imagine a line which is passing perpendicular to this point O, so it will be along the axis of rotation, and hence it is called as an axial vector. Okay, any doubts? If you have any doubts, feel free to ask. So it is the angle covered. I can say angle covered or angle rotated. Okay, so SI unit ಏನಾಗಿರುತ್ತೆ, radians ಆಗಿರುತ್ತೆ. Okay na? SI unit ಯಾವುದು, radians ಆಗಿರುತ್ತೆ. And now ಇಲ್ಲಿ displacement ಬೇಕು ಅಂದ್ರೆ, okay, so this is the displacement. I can call that as delta r ಅಂತ ಬರಿತೀನಿ. Okay, from initial P1 minus P2 ಮಾಡಿದ್ರೆ, or OP1 minus, I mean OP2 minus OP1. So displacement andre linear distance, the shortest linear distance between the given two final and initial position ಆಗಿರುತ್ತೆ. So that is delta r is equals to OP2 minus OP1 vector ಆಗಿರುತ್ತೆ. ಓಕೆ, ಬಟ್ ಇಲ್ಲೊಂದು ಫಾರ್ಮುಲಾ ಇದೆ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ಗೆ, ಬರ್ಕೊಂಡ್ಬಿಡಿ ಡೈರೆಕ್ಟ್ ಆಗಿ. ಸೊ ಡೆಲ್ಟಾ ಆರ್ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಆರ್ ಸೈನ್ 2r sin theta by 2. Okay, so theta is the angle, ಇಲ್ಲಿ d theta ಇದೆ, so ನಾನು ಇಲ್ಲಿ just theta ಬರ್ತಿದ್ದೀನಿ. Theta is the angle between the given two points P1 and P2 ಆಗಿರುತ್ತೆ. Okay, theta is the angle covered between the final position and initial position. Okay, so hope it is clear. Yeah, midterm exam, it depends again on college. College to college change ಆಗಬಹುದು. ಸೆಪ್ಟೆಂಬರ್ ಎಂಡ್ ಒಳಗಡೆ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡಬಹುದು ಆಕ್ಚುಲಿ. Okay, let me only put the box. I hope so. Okay, because before, in the last week of September we can expect midterm. Okay, anyway, one board notification will also come regarding your midterm exam, but I think I have to check. I have not yet seen if there is already a notification regarding midterm dates. Okay, usually there will be some dates will be given. Sometimes it might be the college who will take a call on that. Okay, yeah, hope it is clear. Yeah, so angular coordinates ಯಾಕೆ ಬೇಕು? ಪಾರ್ಟಿಕಲ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ಸ್ ಎಲ್ಲ ಇರೋದು angles ಇದೆ, linear ಆಗಿಲ್ಲ. So we will take angular coordinates like angular displacement. So relation between angular displacement and the normal displacement heng bariತೀವಿ. Yeah, so that for that we can use this formula 2r sin theta by 2. Okay, so next angular velocity. See, now now whatever the new terms we consider, the new one terms, you just compare it to your translatory motion or motion in a 1D case. So allu displacement define ಮಾಡಿದ್ವಿ, next velocity define ಮಾಡಿದ್ವಿ, next acceleration define ಮಾಡಿದ್ವಿ. ಹಂಗೆ ಇಲ್ಲ ಏನ್ ಮಾಡ್ತೀವಿ, angular coordinates ಅಂದ್ರೆ angular displacement, angular velocity, angular acceleration define ಮಾಡ್ತೀವಿ. Okay, so first one, it is defined as rate of change of angular displacement. So velocity ಅಂದ್ರೆ ಏನ್ ಡಿಫೈನ್ ಮಾಡಿದ್ವಿ, ರೇಟ್ ಆಫ್ ಚೇಂಜ್ ಆಫ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಅಂದಿದ್ವಿ. ಅದೇ ತರ ಆಂಗ್ಯುಲರ್ ವೆಲಾಸಿಟಿ ಏನಾಗುತ್ತೆ, ರೇಟ್ ಆಫ್ ಚೇಂಜ್ ಆಫ್ ಆಂಗ್ಯುಲರ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಆಗುತ್ತೆ. ಸೊ ಯೂಶುವಲ್ ನೊಟೇಷನ್ ಒಮೆಗಾ. ಸೊ ಒಮೆಗಾ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಡಿ ಥೀಟಾ ಬೈ ಡಿ ಟಿ. ಓಕೆ, ಯಾ, ಡಿ ಥೀಟಾ ಬೈ ಡಿ ಟಿ. ದಿಸ್ ಇಸ್ ದಿ ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ಆಂಗ್ಯುಲರ್ ವೆಲಾಸಿಟಿ. ಓಕೆ, ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ಆಂಗ್ಯುಲರ್ ವೆಲಾಸಿಟಿ. ನಿಮ್ಗಲ್ಲಿ ಆವ್ರೇಜ್ ಡಿಫೈನ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಒಮೆಗಾ ಆವ್ರೇಜ್. ಸೊ ಏನ್ ಮಾಡಿದ್ವಿ ನಾವು, ಡೆಲ್ಟಾ ಥೀಟಾ ಬೈ ಡೆಲ್ಟಾ ಟಿ ಅಂತ ತಗೊಂಡಿದ್ವಿ. ಚೇಂಜ್ ಇನ್ ಆಂಗಲ್ ಟು ದಿ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಟೈಮ್ ಇಂಟರ್ವಲ್ ಅಂತ. ಅದಕ್ಕೆ ನಾವು ಲಿಮಿಟ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ವಿ ಗೆಟ್ ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ಆಂಗ್ಯುಲರ್ ವೆಲಾಸಿಟಿ. ಓಕೆ, ಒಮೆಗಾ ಇಸ್ ಡಿ ಥೀಟಾ ಬೈ ಡಿ ಟಿ. ಅಗೇನ್ ಯೂನಿಟ್ ಏನಾಗುತ್ತೆ, ರೇಡಿಯನ್ಸ್ ಪರ್ ಸೆಕೆಂಡ್. ಓಕೆ, ಯೂನಿಟ್ ಇಸ್ radians per second. Okay na? Is it clear? Yeah, any doubt? Any doubt? Admit card download ga? I'll just check and let you know. So ನೀವು ಎಕ್ಸಾಮ್ ಡೇಟ್ಸ್ ನ ಕನ್ಫರ್ಮ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀರಾ, ಯಾವತ್ತು ಬರೀತಿದ್ದೀರಾ ಅಂತ? ಐ ಥಿಂಕ್ ಅದೇ ಅಡ್ಮಿಟ್ ಕಾರ್ಡ್ ಲಾಸ್ಟ್ ವೀಕಲ್ಲಿ ರಿಲೀಸ್ ಮಾಡ್ತಾರೆ ಅನ್ಸುತ್ತೆ. ನಾನು ಚೆಕ್ ಮಾಡಿ ಹೇಳ್ತೀನಿ ನಿಮ್ಗೆ. ಓಕೆ, ಇಸ್ ದಟ್ ಫೈನ್? ಯಾ. ಸೊ ನೆಕ್ಸ್ಟ್ we can also have one relation between linear velocity and angular velocity. ಫಾರ್ಮುಲಾ ತಿಳ್ಕೊಳ್ಳಿ ಸಾಕು. Relation between linear velocity and angular velocity. So that is V is equals to omega cross r. Okay. So iduna neevu again rotational motion allu barutte alli derive ಮಾಡ್ತೀರಾ. V is equals to omega cross r. It's a cross product of angular velocity and position vector ಆಗಿರುತ್ತೆ. Omega cross r. So magnitude ಹೆಂಗ್ ಬರೀತೀರಾ? Omega r sin theta. Okay. If theta is equals to 90 degree, then we get V is equals to omega r. So this is true for a particle in uniform circular motion. Uniform circular motion ಏನಾಗಿರುತ್ತೆ? Omega is constant. Okay, take it as a point. So in case of uniform circular motion, so ಏನಾಗಿರುತ್ತೆ? Angular velocity constant ಇರುತ್ತೆ. Omega is constant for uniform circular motion. Okay na? Any doubts? Omega is constant for uniform circular motion ಆಗಿರುತ್ತೆ. And again, angular velocity or omega is a axial vector. Again, you have to find out the direction of angular velocity. ಏನು ಮಾಡಬೇಕು? You have to use your right hand curl rule. Curl along the particle motion such that thumb should be perpendicular to this curling finger and this thumb gives you the direction. Okay, along the axis of rotation. So upward irutta, downward irutta, ಅಥವಾ inward irutta, outward irutta ಅನ್ನೋದು ನಿಮಗೆ ಗೊತ್ತಾಗಬೇಕಂದ್ರೆ you have to use right hand curl rule. So omega direction is along the angular displacement, that is d theta or theta direction ಅಲ್ಲೇ ಇರುತ್ತೆ. Okay, hope it is fine. So next is time period and frequency. Okay, so time period andre usually capital T ಇಂದ represent ಮಾಡ್ತೀವಿ. Frequency is represented by F or sometimes N. Okay, so time period andre ಏನು? Time for one complete rotation. Rotation or revolution. Okay, let us say revolution here. Or time to complete one, one complete circular path. What is the time taken by the particle to complete entire circular path once? That we call it as time period. Okay, so unit ಏನಾಗುತ್ತೆ? Seconds ಆಗಿರುತ್ತೆ. SI unit for, it's nothing but time, right? Time duration. So SI unit of seconds ಆಗಿರುತ್ತೆ. So frequency andre ಏನು? So that is going to be the reciprocal of time period. Okay, so frequency andre reciprocal of time period. Reciprocal of time period or number of revolutions per second. Okay, number of revolutions per second. ಎಷ್ಟು number of rotations ಅಥವಾ ಎಷ್ಟು number of revolutions ಆಗಿದೆ in 1 second is going to give us the frequency. So unit ಏನಾಗಿರುತ್ತೆ? So unit is going to be hertz, which is represented by capital H and small z. Yes. Yeah. Yes, very good, very good. Yes, Kirtan. Okay, unit is going to be hertz, number of revolutions per second or reciprocal of the time period. So again helbod ನಾವು, we can just say that the relation between time period and frequency ಬೇಕು ಅಂದ್ರೆ, so we can quickly say that T is equals to 1 by F or F is equals to 1 by T. Okay, so based on this we can find out, omega one formula baribodu, that is angular velocity. So omega is what? Omega is d theta by dt, or correct? Omega is rate of change of angular velocity. So ಈಗ one rotation ತಗೊಂಡ್ರೆ, okay, let me write in the next page, ಇಲ್ಲಿ space ಸಾಕಾಗೋದಿಲ್ಲ. ಸೊ ಒಮೆಗಾ ಅಂದ್ರೆ ಏನು? d theta by dt. For one complete revolution, what is the angle and what is the time taken? For one complete revolution, so what is the angle theta covered and the time taken? So theta will be equal to 2 pi radians. Hope you agree. So one complete circular path na cover madidre 360 degree cover adange, which corresponds to 2 pi radians, and time enagirutte, that is corresponds to time period capital T agirutte. So we get omega is equals to 2 pi by t, but 1 by t na frequency anta baribodu. So that is going to give us omega is equals to 2 pi f. Okay, so this is another important formula. Yes, hope it is fine. Any doubts? Okay, so moving ahead to angular acceleration. So again, angular acceleration andrenu? Rate of change of angular velocity agirutte. Okay, so rate of change of angular velocity. So it is usually represented by the symbol alpha. So alpha is equals to d omega by dt. Okay, d omega by dt. Alpha is d omega by dt. Rate of change of angular velocity is nothing but angular acceleration. Okay, so unit ಏನಾಗತ್ತೆ? ಒಮೆಗಾ ಯೂನಿಟ್ ಏನಿತ್ತು? ರೇಡಿಯನ್ಸ್ ಪರ್ ಸೆಕೆಂಡ್ ಇತ್ತು, ಇಲ್ಲಿ ರಾಡ್ ಪರ್ ಸೆಕೆಂಡ್ ಸ್ಕ್ವೇರ್ ಆಗತ್ತೆ. ಓಕೆ, ಇಸ್ ಇಟ್ ಫೈನ್? ಯಾ, ಸೊ ಎನಿ ಡೌಟ್? Any doubt till here? So again ಇಲ್ಲಿ angular acceleration ಗೆ ಒಂದು ಫಾರ್ಮುಲಾ ಬರಿಬಹುದು, that is in terms of linear acceleration, a is equals to alpha cross r ಅಂತ ಬರಿಬಹುದು. Okay, and again alpha is 0 for our uniform circular motion. ಆ ಪಾಯಿಂಟ್ ಬರ್ಕೊಳ್ಳಿ, ಯಾಕೆಂದ್ರೆ ಒಮೆಗಾ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ. ಸೊ ಆಲ್ಫಾ ಇಸ್ 0 ಫಾರ್ uniform circular motion. Okay, so alpha is 0 for uniform circular motion because omega constant irutte and differentiation of constant 0 alva. So omega constant aitu andre d omega by dt madidre 0 barutte, but non uniform circular motion alli athwa tangential acceleration idre ಆ ಕೇಸಲ್ಲಿ ನಿಮಗೆ angular acceleration na define ಮಾಡಬಹುದು. Okay, so hope it is clear. Let me just check if any point I have missed. Yeah, it's fine, it's there. Yeah, all the formulas are there till here. Any doubts? If you have doubts, feel free to ask here. Yeah, so next is centripetal acceleration. So idu already nimge idea kottidini nanu. So yes, hello Sanjay, thank you so much. Thank you so much for your wishes on Teachers Day. Thank you so much. Okay, so centripetal acceleration. Centripetal acceleration andrenu? In the case of circular motion, we already have seen that. So ellide, one second, where is that slide? Yeah, so ಏನide ಇಲ್ಲಿ ನಾವು ನೋಡಿದ್ವಿ that the force is acting towards the center of the circle ide, so that the particle is taking a circular path. So whenever we are having some kind of circular motion, it is necessary to have a centripetal force. Okay, centripetal force irodu necessity irutte, and now that particular acceleration we call it as centripetal acceleration. Okay, the acceleration which is acting towards the center, adana ನಾವು centripetal acceleration ಅಂತ ಕರಿತೀವಿ. ಸೊ ಇಲ್ಲಿ ಸಿಂಪಲ್ ಆಗಿ ಒಂದು ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ ವೆಕ್ಟರ್ ನೋಟೇಷನ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಟ್ರೈ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಸೊ ಇನಿಷಿಯಲಿ ಪಾರ್ಟಿಕಲ್ ಇಲ್ಲಿದೆ r ಅನ್ನೋ ಪೊಸಿಷನ್ ಅಲ್ಲಿ, Okay, after some time, I mean P ಅನ್ನೋ ಪೊಸಿಷನ್ ಇದೆ, after some time it has moved to P dash. So ಏನಾಗಿದೆ, P ಇಂದ P dash ಗೆ ಮೂವ್ ಆಗಿದೆ. Okay, so every point ಅಲ್ಲಿ ವೆಲಾಸಿಟಿ ಮಾರ್ಕ್ ಮಾಡಿದ್ದಾರೆ. V that is tangent at P, V dash is the tangent at P dash ಆಗಿರುತ್ತೆ. So ಅದೆರಡರ ಮಧ್ಯದ angle, if you just shift them parallelly, so we see delta V, that is the change in velocity direction ಬರುತ್ತೆ. And we know that acceleration ಬೇಕು ಅಂದ್ರೆ ಏನು, so normal acceleration is dv by dt, and average acceleration ಅಂದ್ರೆ ಏನ್ ಮಾಡಿರ್ತೀವಿ, ಡೆಲ್ಟಾ ವಿ ಬೈ ಡೆಲ್ಟಾ ಟಿ ತಗೊಂಡಿರ್ತೀವಿ, ಕರೆಕ್ಟಾ? ಸೊ ಇಲ್ಲೇನಾಗಿದೆ, ಡೆಲ್ಟಾ ವಿ ಡೈರೆಕ್ಷನ್ ಎಲ್ಲಿದೆ, ಇಟ್ ಈಸ್ ಆಕ್ಟಿಂಗ್ ಟುವರ್ಡ್ಸ್ ದಿ ಸೆಂಟರ್, ಕರೆಕ್ಟಾ? ಸೊ ಇಲ್ಲಿ ವಿ ನ ಶಿಫ್ಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಪ್ಯಾರಲಲಿ, ದ ಚೇಂಜ್ ಇನ್ ವೆಲಾಸಿಟಿ ಡೈರೆಕ್ಷನ್ ಏನ್ ಬರುತ್ತೆ, ಇಟ್ ಈಸ್ ಆಕ್ಟಿಂಗ್ ಟುವರ್ಡ್ಸ್ ದಿ ಸೆಂಟರ್ ಬಂದಿದೆ, ಅಂದ್ರೆ ಆಕ್ಸಿಲರೇಷನ್ ಡೈರೆಕ್ಷನ್ ಆಕ್ಟಿಂಗ್ ಟುವರ್ಡ್ಸ್ ದಿ ಸೆಂಟರ್ ಆಗತ್ತೆ. ಈಗ ನಾವು ಆವರೇಜ್ ಆಕ್ಸಿಲರೇಷನ್ ಇಂದ ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ಆಕ್ಸಿಲರೇಷನ್ ಏನ್ ಮಾಡಿರ್ತೀವಿ, ಡೆಲ್ಟಾ ಟಿ ಟೆಂಡಿಂಗ್ ಟು ಝೀರೋ ಲಿಮಿಟ್ ನೊಟೇಶನ್ ತಗೊಂಡಿರ್ತೀವಿ ಅಲ್ವಾ? ಸೊ ಹೆಂಗ್ ಡಿಫೈನ್ ಮಾಡಿರ್ತೀವಿ, ಎ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಲಿಮಿಟ್ as delta t tending to 0 delta v by delta t ಅಂತ ತಗೊಂಡಿರ್ತೀವಿ, if you can remember from your 1D and 2D motion. Okay, so change in velocity direction ಏನಿದೆ, it is acting towards the center ಇದೆ, and ನಾವೀಗ ಡೆಲ್ಟಾ ಟಿ ನ as small as possible, ಈ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ನ ಕಡಿಮೆ ಮಾಡ್ತಾ ಬರ್ಬೇಕು ಅಂತ ಅರ್ಥ. ಟೈಮ್ ಕಡಿಮೆ ಆದಂಗೂ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕಡಿಮೆ ಆಗುತ್ತಲ್ವಾ? ಸೊ ಆ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ವಿ ಗೆಟ್ ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ವೆಲಾಸಿಟಿ ಅಂಡ್ ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ಆಕ್ಸಿಲರೇಷನ್ ಆಗುತ್ತೆ. ಸೊ ಅಲ್ಲಿ ವೆಲಾಸಿಟಿ ಟ್ಯಾಂಜೆನ್ಷಿಯಲ್ ಡೈರೆಕ್ಷನ್ ಇರುತ್ತೆ, ಆಕ್ಸಿಲರೇಷನ್ ವಿಲ್ ಬಿ ಆಕ್ಟಿಂಗ್ ಟುವರ್ಡ್ಸ್ ದಿ ಸೆಂಟರ್ ಆಫ್ ದಿ ಸರ್ಕಲ್ ಆಗುತ್ತೆ, ಅಂಡ್ ಇದನ್ನ ನಾವು ಸೆಂಟ್ರಿಪಿಟಲ್ ಆಕ್ಸಿಲರೇಷನ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆ, ಆಸ್ ದ acceleration is acting towards the center in the case of uniform circular motion, we call it as centripetal acceleration. So that is given by the formula v square by r. Okay, so formula v square by r. Centripetal acceleration AC is equals to v square by r, ಅಥವಾ v ನ omega into r ಅಂತ ಬರಿಬಹುದು. So omega r whole square by r, which will give you omega square r. Okay, so this is one another formula. Okay na? Yeah, so centripetal acceleration ಏನಾಗುತ್ತೆ, omega square r. Hope it is fine till here. ರಿಯಲ್ ವರ್ಲ್ಡ್ ಅಪ್ಲಿಕೇಶನ್ ಸುಮಾರು ಇದೆ ಅಲ್ಲ, ಸ್ಪೋರ್ಟ್ಸ್ ಎಲ್ಲ ಎಷ್ಟಿದೆ, ಜಾವ್ಲಿನ್ ಥ್ರೋ ಇದೆ, ಫುಟ್ಬಾಲ್, ಹೌ ಯು ಕಿಕ್ ದ ಬಾಲ್, ಯಾ ವಾಟ್ ಇಸ್ ದ ಟ್ರೆಜೆಕ್ಟರಿ ದಟ್ ಇಸ್ ಟೇಕನ್ ಬೈ ಇಟ್, ಅಂಡ್ ಆಸ್ ವಿ ಡಿಸ್ಕಸ್ಡ್ ಹಾರಿಜಾಂಟಲ್ ಪ್ರೊಜೆಕ್ಟೈಲ್ ಮೋಷನ್ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ, ಟು ಫಿಕ್ಸ್ ದಿ ಟಾರ್ಗೆಟ್ ಎಲ್ಲಿದೆ, ಎಲ್ಲಿಂದ ವೆನ್ ದರ್ ಇಸ್ ಸಮ್ ಎನಮಿ ಟಾರ್ಗೆಟ್ಸ್, ಹೌ ಟು ಬಾಂಬ್ ಇಟ್ ಆರ್ ಹೌ ಟು ಫೈಂಡ್ ಇಟ್, ಸೊ ಅಲ್ಲೆಲ್ಲ ಟಾರ್ಗೆಟ್ ಫಿಕ್ಸ್ ಮಾಡಬೇಕು. So many cases ಇದೆ. All this circular motion is the example for your motion in a plane. Okay, ನೀವು ಒಂದು ಸರ್ಕಸ್ ಅಲ್ಲೆಲ್ಲ ನೋಡಿರ್ಬೋದು, ಅದಕ್ಕೆ ಏನಂತಾರೆ, ಡೆತ್ ವಾಲ್ ರೊಟೇಷನ್ ಅಂತ. ವರ್ಟಿಕಲ್ ವಾಲ್ ಇರುತ್ತೆ, ಅಲ್ಲಿ ಬೈಕ್ ಅಲ್ಲಿ ಇಲ್ಲ ಸೈಕಲ್ ಅಲ್ಲಿ ಅವ್ರು ರೊಟೇಟ್ ಮಾಡ್ತಾರೆ, ನೋಡಿದೀರಾ? ವರ್ಟಿಕಲ್ ವಾಲ್ ಅಲ್ಲಿ, ಹಾರಿಜಾಂಟಲ್ ಅಲ್ಲ. ಸೊ ಮೆನಿ ಕೇಸಸ್ ಇದೆ. Okay, next is centripetal force. So ಇದನ್ನ ನಾನು ಡೈರೆಕ್ಟ್ ಆಗಿ ಕೊಡ್ತೀನಿ, ಏನು ಸೆಂಟರ್ ಸೀಕಿಂಗ್ ಫೋರ್ಸ್. ಸೆಂಟ್ರಿಪಿಟಲ್ ಅಂದ್ರೆ ಸೆಂಟರ್ ಸೀಕಿಂಗ್ ಫೋರ್ಸ್. ಸೊ ವೆನ್ ಎ ಪಾರ್ಟಿಕಲ್ ಇಸ್ ಮೂವಿಂಗ್ ಇನ್ ದಿ ಯೂನಿಫಾರ್ಮ್ in the uniform circular motion with uniform force, ಅಲ್ಲಿ ಫೋರ್ಸ್ ಶುಡ್ ಬಿ ಆಕ್ಟಿಂಗ್ ಅಲಾಂಗ್ ದಿ ರೇಡಿಯಲ್ ಡೈರೆಕ್ಷನ್ ಆಗಿರುತ್ತೆ. ಟ್ಯಾಂಜೆನ್ಷಿಯಲ್ ಡೈರೆಕ್ಷನ್ ಇದ್ರೆ ಸ್ಪೀಡ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರಲ್ಲ. ಓಕೆ, ಅಲ್ಲಿ ನಿಮ್ಗೆ ಟ್ಯಾಂಜೆನ್ಷಿಯಲ್ ಫೋರ್ಸ್ ಟ್ಯಾಂಜೆನ್ಷಿಯಲ್ ಆಕ್ಸಿಲರೇಷನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು. Okay, but uniform circular motion ಅಲ್ಲಿ ನಾವು ಅದನ್ನ ಡಿಸ್ಕಸ್ ಮಾಡಲ್ಲ. Whenever you are having uniform circular motion, speed of the particle is constant, and ಆ ಕೇಸ್ ಅಲ್ಲಿ ಬರುವ ಫೋರ್ಸ್ ಅನ್ನ ಏನಂತ ಕರಿತೀವಿ, centripetal force ಅಂತ ಕರಿತೀವಿ, which is given by F is equals to mv square by r. That is, force is mass into acceleration, m into centripetal acceleration. Centripetal acceleration is v square by r. Okay, or again ಏನ್ ಬರಿಬಹುದು, m omega square r. So this is the expression for centripetal force. Hope it is clear. Any doubt? If you have doubt, feel free to ask. If you're following the session, please give me a thumbs up and also do like the session. And if you're new to the channel, please do subscribe to the channel. Okay, we'll quickly take 2-3 problems and then we'll wind up with the session. So first question, in uniform circular motion, the velocity vector and acceleration vector are. It's a simple question. Uniform circular motion, what is the angle between velocity vector and acceleration vector anta ide? They are perpendicular to each other. If you just quickly go back to this diagram, it is very clear. Our acceleration is here, velocity is acting tangentially, acceleration is radial. So we know that tangent and radius are always perpendicular to each other iratte. Okay, hope it is fine, I guess. So uniform circular motion idre alli tangential acceleration iralla. Okay, so that is at will be 0. Whatever is there, that is only centripetal or radial agirutte. Okay na? And radial acceleration, it will be acting towards along the radius. Velocity is always tangent, so angle between them will be 90 degree, perpendicular to each other. Okay, so next question. Any doubts? If you have doubts, feel free to ask here. Okay. Okay, so a 500 kg car takes a round turn of radius 50 meter with a velocity of 36 km per hour. Centripetal force is. So centripetal force find out madbeku. So the car is taking a turn of radius 50 meter anta ide. So centripetal force formula F is equals to mv square by r ಆಗಿರುತ್ತೆ. So ಈಗ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಣ. ಓಕೆ, ಸೊ ಏನೇನು ಕೊಟ್ಟಿದ್ದಾರೆ, ಮಾಸ್ ಎಷ್ಟಿದೆ 500, ವಿ ಸ್ಕ್ವೇರ್ ಎಷ್ಟಾಗುತ್ತೆ, ಇಲ್ಲಿ ವೆಲಾಸಿಟಿ ಕಿಲೋಮೀಟರ್ ಪರ್ ಅವರ್ ಅಲ್ಲಿ ಇದೆ 36 ಕಿಲೋಮೀಟರ್ ಪರ್ ಅವರ್. ಸೊ ಅದನ್ನ ನೀವು ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. 36 ಇಂಟು 5/18 ಮಾಡಿದ್ರೆ ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡಿಗೆ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. ಓಕೆ, yeah, so please remember how to convert from kilometer per hour to meter per second. So you had to multiply by 5/18, or this is going to give you velocity as 10 meters per second agate. Correct? So illi enagate 10 square divided by the radius, which is 50. So can you quickly simplify this and let me know what is the value of centripetal force we are getting. So this 0, this 0, this is 1, and this is 10 so that is going to give us 1000 newtons. 10 cube agatte 1000 newtons baratte, hauda? Yeah, yes. So that is option 3 is going to be the correct answer. Okay, centripetal force andre mv square by r, ಅದೇ ಫಾರ್ಮುಲಾ. ಓಕೆ, ಇಲ್ಲಿ ವೆಲಾಸಿಟಿ ಕೊಟ್ಟಿದ್ದಾರೆ, ಇನ್ ಕೇಸ್ ಆಂಗ್ಯುಲರ್ ವೆಲಾಸಿಟಿ ಕೊಟ್ಟಿದ್ರೆ m ಒಮೆಗಾ ಸ್ಕ್ವೇರ್ r ಫಾರ್ಮುಲಾ ಹಾಕೋಬೇಕು. ಓಕೆನಾ? ಸೊ ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್, ದ ಆಂಗ್ಯುಲರ್ ಸ್ಪೀಡ್ ಆಫ್ ಫ್ಲೈವೀಲ್ ಮೇಕಿಂಗ್ 120 ರೆವಲ್ಯೂಷನ್ಸ್ ಪರ್ ಮಿನಿಟ್. ಸೊ ಆಂಗ್ಯುಲರ್ ಸ್ಪೀಡ್ ಅಂದ್ರೆ ಏನ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು ನೀವು, ಒಮೆಗಾ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಓಕೆ, ಸೊ ಒಮೆಗಾ ಅಂದ್ರೇನು, ದಟ್ ಇಸ್ ಥೀಟಾ 2π/t. ಓಕೆ, or 2πf. ಇಲ್ಲಿ revolutions per second ಇದೆ, I mean revolutions per minute ಇದೆ. ಸೊ revolutions per second ಅಂದ್ರೆ ನಮಗೆ ಗೊತ್ತು ಅದು ಫ್ರೀಕ್ವೆನ್ಸಿ. ಓಕೆ, ಸೊ ಫಾರ್ಮುಲಾ ಯಾವ್ದು ಯೂಸ್ ಮಾಡ್ಬೋದು ಆಗ, ಒಮೆಗಾ ಇಸ್ 2πf ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡ್ಬೋದು. ಐ ಥಿಂಕ್ ಐ ಜಸ್ಟ್ ಗೇವ್ ಯು ಹಿಯರ್ somewhere here, ಕರೆಕ್ಟ್? ಒಮೆಗಾ ಇಸ್ 2πf ನಮಗೆ ಗೊತ್ತಿದೆ. ಅಲ್ಲಿ ಟೈಮ್ ಪೀರಿಯಡ್ ಕೊಟ್ಟಿದ್ರೆ 2π/t ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೆ. ಓಕೆ, ಬಟ್ ಇಲ್ಲೇನಾಗಿದೆ, ಫ್ರೀಕ್ವೆನ್ಸಿ ಕೊಟ್ಟಿರೋದು, ಅದಕ್ಕೆ ನಾನು ಒಮೆಗಾ ಇಸ್ 2πf ಅಂತ ತಗೊಂತೀನಿ. ಸೊ ಫ್ರೀಕ್ವೆನ್ಸಿ ಎಷ್ಟಾಗತ್ತೆ ಈಗ, ಫ್ರೀಕ್ವೆನ್ಸಿ ಇಸ್ 120 ರೆವಲ್ಯೂಷನ್ಸ್ ಪರ್ ಮಿನಿಟ್ ಅಂತಿರೋದು. ಸೊ ಪರ್ ಮಿನಿಟ್ ಅಂದ್ರೆ ಡಿವೈಡೆಡ್ ಬೈ 60 ಅಂಡ್ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಅಷ್ಟೇ. ಒಮೆಗಾ ಇಸ್ 2π ಇಂಟು 120 divided by 60. So this is going to be per second, or I can say like hertz. ಎಲ್ಲವನ್ನು SI ಯೂನಿಟ್ ಅಲ್ಲೇ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. ಓಕೆ, so this is 1 this is 2 so what we are going to get, omega is going to be 4π. 4π ಯೂನಿಟ್ ಏನಾಗುತ್ತೆ ಒಮೆಗಾ ಅಂದ್ರೆ ರೇಡಿಯನ್ಸ್ ಪರ್ ಸೆಕೆಂಡ್. Okay na? Radians per second. Is that fine? Any doubt? Omega is 4 pi radians per second. That is option 4 is the correct answer. Okay. Angular speed andre 2 pi f or 2 pi by t. Look into the given data, use the corresponding formula. Is that fine? Any doubts? If you have doubts, please ask in the chat box, or else I'm just going to end the session for the day as the time is up, and I think Catherine ma'am is also waiting for the session. I'll just end for today. Okay. So in the next class,